we were seeing the potential due to a continuous charge distribution. So we considered case of a thin spherical shell. The distance or the radius of this spherical shell is capital R, and first let us say the point is outside, this point P is outside, and this is at a distance small r. So we found that there is an electric field at this point as the whole charge is concentrated at the center of this spherical shell. So similarly potential is 1 upon 4 pi epsilon naught charge and distance, total distance r. So this is the potential outside at any point outside this thin spherical shell. But in the second case we saw that the electric field at any point inside this sphere, thin spherical shell, was 0. Electric field was 0. But the potential will not be 0. The potential will not be 0. The potential is a constant potential. The potential inside this thin spherical shell is not 0. It is a constant potential, which is this. V is equal to 1 by 4 pi epsilon naught Q upon R. Now you have to understand this property, that the electric field and potential. Electric field is simply the differential of this potential. Differential. This is differential of this potential. Okay. And potential is simply the integration of this electric field. Integration. And you know the integration of any zero is a constant. If you have a zero term here and integrate, so you will get a constant, or reverse, if you differentiate a constant term, differentiation of a constant term is always equal to 0. So if this potential is constant, that means differentiation is 0, hence electric field is 0. Let us understand in a different way. So let us take, there are 2 points, point 1, point 2. Here we have a potential V1, here we have a potential V2. So let us take V1 is higher than V2. So that means this is positive, this is negative. So that means there must be some electric field lines from positive to negative, and if you find electric field lines from positive to negative, that means there is electric field which is not 0. Okay. So the potential has a difference. V1 is more than V2, hence there must be an electric field. Let us take another case. Now we again have 2 points, point 1 and point 2. So potential at this point is V1, potential at this point is V2, but this time V1 and V2 both are equal. That means potential is constant. It was different potential, different. Here it is constant potential. Now the potential is constant. So neither this is positive nor this one is positive. No one is positive, no one is negative. Hence there would be no electric field. Hence electric field would be 0. That's what I am trying to say. If the potential at each and every point is constant, there would be no electric field. Again, let us go to the case of this thin spherical shell. Outside there was electric field, E is not equal to 0. V is also not equal to 0. But inside what we found is E equal to 0 inside. E is equal to 0. This V is also not equal to 0, and E is equal to 0 while V is equal to constant. So let us take 2 points inside. One point is here, another point is here. This is point 1, this is point 2. So potential at this point is V, and potential on this point is also V, because V is constant. V is constant inside. What is the constant? 1 upon 4 pi epsilon naught. This is a constant. Total charge in the spherical shell, this is also constant. Total charge, the radius of the spherical shell, that is also constant. So all the quantities are a constant, hence the potential must be a constant. So the potential at this point is V, potential at this point is V. So neither of them is positive nor negative. So hence there will be no electric field, hence electric field is equal to 0. So this was the case, that why electric field is 0 even if there is a potential, because potential is constant. Now let us solve this numerical problem. Example 2.2. Now they have two charges. This is first charge, 3 into 10 to power minus 8. Another charge is negative, minus 2 into 10 to power minus 8 coulomb. They are located 50 centimeter apart. So this is first charge Q1, this is second charge Q2, this is positive, this is negative, and the distance between them is 15 centimeter. Now they are trying to say at what point on the line joining the two charges electric potential is 0. So V must be 0 at what point? So we need a condition where potential due to this charge, since this is positive and this is negative, so there must be a point where potential is equal to 0 due to superposition. V is equal to V1 plus V2. This one is definitely positive, this one is negative, so there must be a point where potential is 0. This is very similar to the question where this is earth and this is moon, and we found a point between them where gravitational field is 0, G is equal to 0. This is very similar to that. So here the gravitational acceleration was 0, here potential is 0. So now we have to find that point. So this is the simple question we have to find. Now let us consider that this is charge Q1, this is positive, and this is bigger than this. This is minus 2, this is plus 3. So this is another charge Q2, this is negative, but this is small, this is large, L large, this is small. So now if we join them by a line, so this is 15 centimeter. The distance between them is 15 centimeter. So now this is positive charge, this is negative charge. Negative charge is small. So there would be potential. This has a higher potential, so it will go much further. And this has a lower potential, so this will go lesser distance. So there is a point in between where we will get a potential equal to 0. Potential equal to 0. Now this is first case where the point lies between these two points. Second case, this is Q2, this is Q1. If we consider point on the left side, the distance between this Q1, this is Q1. Distance due to this Q1 is always small, so hence potential will be more, and distance this Q2 is always high, more, so potential will be less. So that is potential of 1 is always greater than potential, we are talking about the magnitude, will always be greater because potential is proportional to 1 by r. So no point can be on the left side, no point, because this will never get to a 0. Now let us take third condition. This is Q1, this is large, this Q2 is small. So let us take a point here. So this point is some distance from here, another distance from here. So for this distance is R1, for this distance is R2. So now you know that if the distance is such a way that effect of this and effect of this R2 will be equal, in that case we can have a 0 point. So in total we can have three conditions. If the point on this axial line is between the charges, here, it can be here, it can be here. So it cannot be on the left side. This possibility is neglected because left charge is positive and bigger. It could be on right side because right charge is smaller and hence at a smaller distance its effect would be higher than this. So the point could be on the right side as well as in between. So we will solve for these two cases, point on the right side, point in the middle.